So my name is Nihar Bihani. I'm a product manager at Amazon Web Services. The specific team that I'm part of is Amazon Cloudfront, which is our content delivery service, our CDN. And then I'm joined here today with Jeroen from JW Player. So what we're talking about today is secure media streaming and delivery. And let's quickly run through the agenda. There are four things that I'd like to, that Jeroen and I would like to cover today. First, I'll give a quick overview of the AWS platform for media delivery. Then talk a little bit about a couple of services, specifically Amazon Cloudfront and also Amazon Elastic Transcoder, which is our transcoding service, and dive a little bit deeper into the security features that are available within those services, because we're talking about the security elements of delivering a video stream. Jeroen will talk about JW Player and talk about some of the security features available on the client side within the Player product that Jeroen provides. And then we'll do a quick demo on how you can deliver a secure on-demand stream using AWS as well as JW Player. So, this is just a high-level overview of AWS. There is a variety of different services for many different use cases that are available within the Amazon Web Services cloud. We're not going to cover nearly all of these today. Like I said, we'll dive into a couple of these services. But I wanted to highlight this because when it comes to media delivery or maybe any other use case that you have, there's different options that are available, including AWS Marketplace and software that's available on the AWS Marketplace that you can use to create and build your own stack to deliver your content. Specifically, when you think about media, the way at least I like to think about it and I talk to customers about is the different stages of delivering media. You start with ingest, you sort of create your media content and you store that in something like an Amazon S3, which is our storage service. Then next would be processing that content. So you use Amazon Elastic Transcoder to transcode that into formats that your viewers can consume with the devices that they're using. And then finally, for delivery, you can use Amazon Cloudfront as a CDN. So, regardless of what your use case is for media processing and delivery, again, there's a number of different options available from S3, EC2, which is our Elastic Compute Cloud, Elastic Transcoder, as well as Cloudfront. So from a security perspective, the key takeaway that I'd like you to have from this slide is there are multiple options available when it comes to securing your media content. Which of these options or which of these features you choose to implement really depends on your specific use case and on what level of security you feel comfortable with when delivering your content. One great thing about AWS is that there is a variety of different types of use cases or types of customers that are using AWS. All the way from very simple use cases where just doing something like token or signed URL-based authentication is good enough or sufficient, to going all the way to AES encryption, DRM, geo-blocking, and watermarking, and potentially using all of those in combination for something like a first-run Hollywood movie, for instance, where you want to make sure that that content does not get leaked or released prior to a scheduled date and time to anyone, because you want to protect it with everything that's out there. Specifically, within Cloudfront and Elastic Transcoder, you'll see I've highlighted a number of different features that are available in those two services that help you implement easily some of these options depending on, again, what your needs are. So Cloudfront provides a private content functionality where you can use signed URLs or signed cookies. With Amazon Elastic Transcoder, you can do AES encryption. Transcoder also has recently added the capability for DRM packaging for PlayReady. With Amazon Cloudfront, you can do geo-restriction, so you can either whitelist or blacklist countries from where you want your viewers to access or not access your content. And then Transcoder also provides visual watermarks where you can have a unique fingerprint on each video that you're transcoding. So let's say as you're distributing it out to your different partners, so that you know which partner has which version of the video. A very simple architecture diagram here. If you look at the top, and if you start from the right and go left, you see a media file that you can store in an Amazon S3 bucket. That S3 bucket then becomes the source for Amazon Elastic Transcoder. The Transcoder service will get the media file from that bucket, transcode the media file, and then the outputs can be stored again in another Amazon S3 bucket. And then that Amazon S3 bucket serves as the origin for Amazon Cloudfront, which is the content delivery service. And then Cloudfront can be accessed, or your viewers can use, when they're on different devices, they can access your encoded media files from Cloudfront and stream them. In the bottom, you'll see, again, if you go from right to left, that's the live stream scenario. And there you see there's an RTMP stream that's being captured by a device, like a video camera, that you are then sending to an Amazon EC2 instance, which is running a media server, and that media server is doing the encoding of that stream in real time. And then that media server serves as the origin for Cloudfront again, and your clients can use Cloudfront or access that live stream from Cloudfront. So just wanted to highlight how you can use a combination of some of these services to architect very simply an on-demand stack or a live streaming stack on AWS. So let's dive a little bit deeper into a couple of the services. First is Cloudfront. So Cloudfront is a global content delivery service. We have 53 edge locations across 37 cities. So it's a global CDN that supports both on-demand and live streaming use cases. HTTP as well as RTMP streaming, and also there's native support for smooth streaming, so you don't need to run any media servers. You can simply upload your file into Amazon S3, and Cloudfront will make sure to deliver it to smooth streaming clients. You can also set different TTLs, or time to lives, so how long you want your manifest file in the case of HLS, and also your fragments to be cached. One of the benefits that you get by using a CDN is the cacheability and the scalability, so you don't have to worry about that as you see traffic spikes for your use case, or if your content becomes popular, then a CDN can help you scale very easily. TCP optimizations are there by default. These help improve the connections between Cloudfront, the edge locations of the CDN network, and the origin servers like an S3 bucket or EC2, so that we can provide the high throughput that you need for delivering a large video file. And then the last thing I'd say there is you can also customize the content at the edge. So we talked about geo-restriction. You can also do language-based customization or different types of devices that your viewers may be using, a tablet versus a mobile phone or a desktop. From a security perspective, since we're focused on security today, Cloudfront has multiple different security features. You can do SSL and use your own SSL certificate, so you can use your own domain name in the URL. You can redirect HTTP requests over to HTTPS, so to ensure that all of your viewers are accessing content over HTTPS. You can do signed URLs or cookie-based authentication, and cookie-based authentication is something that we'll do a quick demo of as well. Amazon Elastic Transcoder, like I said, this is the transcoding service. It's a highly scalable, cost-effective service. If you think about it, when you're doing transcoding, with a service like Amazon Elastic Transcoder, you don't need to worry about the cost of different codecs or licensing. Those are all baked into the cost of the service. So you can simply use this service and pay one price, and it takes away all of that heavy lifting from you. It's integrated with a lot of different AWS services, and we showed in the architecture diagram how it can talk to S3 and put the outputs back into S3. Supports different codecs. You can also do audio-only processing with, if you're doing podcasts or things like that, you can just do audio encoding with Transcoder as well. And, it's a fairly feature-rich service. You can do captions, visual watermarks, clipping. We added DRM support recently, as I discussed. From a security of the Transcoder service, Transcoder supports encryption at rest, so it can, get your encrypted files from Amazon S3, decrypt them, supports both client-provided as well as server-provided keys, encode the files and then encrypt them again and put them back into an Amazon S3 bucket. So from a security perspective, encryption is totally supported with Transcoder, with Amazon Elastic Transcoder. It integrates with the key management service. So the AWS Key Management Service helps you manage your encryption keys. So it actually takes your keys and encrypts them and stores them for you. The Transcoder service will also encrypt your HLS streams, so the HLS fragments. Once it transcodes your video file, those fragments can be encrypted and then stored into the S3 bucket. And then also has support for AWS Cloud Trail. I'll quickly cover Cloud Trail is a service that helps you monitor from a management perspective, who's accessing your AWS resources. So for Amazon Elastic Transcoder, you can use the Cloud Trail service and look at the logs and see who's actually doing the transcoding, or who's accessing your AWS resources. So at this point, Jerome will talk a little bit about JW Player.
Thanks. So Amazon Cloudfront covers the server-side part. JW Player, we're going to cover the client-side part, actually, the playback of the secure streams. So what is JW Player? For those not familiar with the video player, it's the video player on the right. It's a player that is most well known for its playback in websites, both in Flash and HTML5 mode. But we also have native frameworks for both iOS and Android. So if you're building native apps, you can drop JW Player in there and then have all the analytics and adaptive streaming fixes and capabilities that you also expect from on the website from JW Player. And then last, we support OTT platforms with a kind of like point-and-click Chromecast integration, and we also support Apple's AirPlay. So if you're looking at purely on the website of things, what is JW Player different than a video tag? So first, there's lots of work that our team is doing in terms of cross-device support. So we're making sure that the things that are not supported on, think about something like IE8, is going to get supported within JW Player. The API is the same across all the browsers and across all the devices, mobile and desktop. And the skinning is also the same across mobile and desktop. And then skinning is a really important part for brands, enterprises, so really get a premium, like a Netflix, Hulu style user interface, not a bunch of controls that look different everywhere, but very consistent, your brand, and lots of functionality around showing those little preview markers that you see in this screenshot, social sharing buttons, integrations with Facebook and Twitter, recommendations for additional content so people keep watching your video. All these kind of features are packaged up into our interface. And then the third big benefit of JW Player on the website is that we natively support Apple's HLS protocol on desktops. So whereas Apple's HLS protocols in the browsers only works on iOS devices and Android, we've actually built a layer into our player that like ingests that HLS, plays it out with high performance, high quality, and support for all the features of the HLS standard, including things like multiple audio tracks and closed captioning. So on the security side specifically, there's a wide range of functionality JW Player support. So similar to Cloudfront, we support CDN access tokening. So if you set tokens on the Cloudfront side, JW Player will be able to accept them and play out the content. Geo and domain restrictions, that's other items JW Player supports. Brand new is our support for DRM with MPEG-Dash. So this is support for next generation DRM standards-based using MPEG-Dash and common encryption and leveraging the HTML5 APIs. You can see a little matrix on the right side of what we do there. So we support Widevine on Google's Chrome, both on desktop and on Android. Primetime for Firefox and Safari, and then Play Ready for Internet Explorer. So that kind of covers all the big browsers, and you can, with a combo of those DRMs, you're kind of like future-proofing your secure streaming. DRM is pretty cumbersome to set up, and it's pretty high-end. So we also support a more pragmatic approach, as we like to call it, Hls Aes Encryption. So we support AES encryption across all browsers, mobile and desktop. And a new feature that we launched a couple months ago is one we'll demo here, that we can also accept tokening for AES. So your key files can be secured either through a cookie or through a signature that gets appended to the key file. So not everybody can grab your key and kind of like in their own third-party app decode your streams. I think at this point we want to move into the demo.
Right, so Jeroen and I will do a quick demo, live demo, which is always a bit dangerous, but we'll give it a try. So what we wanted to show is a secure on-demand stream using AWS and JW Player. So just a quick overview of what we're doing. The different AWS services that we'll use for this demo: Amazon S3 for storage, Amazon Elastic Transcoder for the transcoding and the encryption, Amazon Cloudfront for delivery, and also the Aws Key Management Service, which manages your keys that you use for encryption and decryption. JW Player for delivery. And really the benefit, I mean, you could do all of this by yourself, to a large extent, but the benefit of using some of these services in JW Player is that you get the high availability, scalability, and the cost that's sort of already baked into these services, and you don't have to go and try to do these things on your own. So just a quick architecture, just to show you what we'll be doing here. So you've got the media owner that has a media file, and they're sending that file to the Amazon S3 bucket. The media owner also has a key that they're going to use for encrypting that file, and they send that key to the AWS Key Management Service. Key Management Service will encrypt that key and send the encrypted key back to the media owner. The media owner then sends that encrypted key to Amazon Elastic Transcoder, which is the transcoding service. The transcoding service already knows how to communicate in the background with the key management service. So the transcoder will then use that encrypted key, get an unencrypted key or a decrypted key from the key management service, get the media file from Amazon S3, decrypt your media file, transcode it, and then encrypt the output and send the output to the output S3 bucket. Now this output S3 bucket has your encrypted, transcoded media file. You can deliver that via Amazon Cloudfront, the content delivery service, to the user who's using JW Player in this case. Now JW Player or the user's device has this encrypted media file. It needs to decrypt it somehow, so it needs the keys. So you could build a very simple application, which is what I'm showing on the right-hand side there. We're using Elastic Load Balancer and a couple of EC2 instances, and you authenticate your users, and you basically, those EC2 instances can talk to the key management service again, get the decrypted keys back, and send those decrypted keys after you've authenticated your user to the client. So now the client has the keys and an encrypted file that it can now decrypt and play via JW Player for your viewers. So that's sort of the architecture at a high level. We'll flip to the browser here. So what I've done is I've set up a very simple, that is not showing up. There we go. Okay, so what I've done is I've set up a very simple application here. It's called edgereinvent.com. And if you go to HLS, and in HLS, if you look down here below, I've got a number of different videos, but the one that I'll be demoing here is a NASA launch video, and it says auth required. So what that means is that your user needs to be authenticated, and they need to have a cookie that the CDN will check before actually serving that content to your user. So if I go to the auth required video and I try to play this right now, it's giving me an error because I don't have that cookie. So let me go and get myself authenticated. So I go to the signed content section, and here, let's see, I'm gonna, give myself a cookie as if I've purchased this video, for instance, and I've gotten the right cookie, and now I'm going to go ahead and play this video. And as you can see now, the CDN has authenticated me, and it's playing the video. And if you look here, if I refresh, you can see the 3 cookies that are now available on the browser that the CDN is checking for before delivering every single fragment to the player. And then I'll have Jeroen, he can show a little bit about the actual player setup. So we're using JW Player here, but Jeroen can show you how you can configure JW Player for a delivery like this.
Yep, here we go. Yeah, I think so. On the so what I'll show is quickly to like how to set up JW Player such that it loads this encrypted, authenticated stream. Let me grab that one. I think it's in here. Huh? Yeah, here it is. So we're setting up the stream in JW Player. So when you sign up for a JW Player account, this is part of your console. We basically call this our publishing wizard. In there, you can see the video. You can change a couple of items very swiftly on the player side in terms of skinning. The video plays. I believe you were using this skin, our Stormtrooper skin, since it's Star Wars is coming up. And then there's more functionality in JW Player, both in the interface, in terms of advertising and styling, and definitely more on the developer side in terms of APIs. But at this point, everything is ready to go, and you can copy paste this video right into your website. And as you can see, there's only one video URL embedded in here. So it's not if this browser do this stream, if that browser do that stream. There's one secure adaptive HLS stream that's gonna play on your Android devices, iOS devices, Internet Explorer, Firefox, Safari, Chrome, Opera, all your web and mobile browsers.
Okay, great. I think that's all we have. Thank you again for coming to the session. We'll be happy to take questions. I think we're out of time. So
We are out of time. So
Yeah, it's 12:30.
If you have questions, come on up and ask me or JW, and we have chosen the winner for the
Okay.
Amazon Fire TV.
Great. Okay, so it's Nikolai. Nikolai here. You. Okay. All right.
All right, thank you very much.
Thank you.